Well, good morning to all of you. This is Karothiya, and today I would like to talk about the refrigerant. Myself, assistant professor at Department of Mechanical Engineering, IIMT College of Engineering, Greater Noida. So today topic content will be the history of refrigerant, then their classification. In that classification, we will discuss halocarbon, azeotrophs, hydrocarbons, organic compound. After that, there will be desirable properties of a ideal refrigerant, then refrigerant and its applications, then methods and equipments for determining the refrigerant leaks, then ozone depletion potentials, global warming potentials, and the future of refrigerants. So, if you talk about the history of refrigerant, so the substance capable of absorbing heat from another required substance space can be used as a refrigerant basic. So air was used as a refrigerant in olden day in many refrigeration systems because most safest and cheapest refrigerant. First refrigerant uh, used generally ether, which is employed by Parkins and Hop, which was the hand-operated vapor compression machines. Then it was ethyl chloride, and after that ammonia in 1875. And after that, generally the scientists or researchers have used the methyl chloride for domestic and commercial refrigeration. So if we talk about the classification of refrigerant, there are two type of classification. First is the primary and secondary refrigerant. Primary, generally we say that these are the substance or refrigerant which directly take place participation to absorb the heat from the storage place, like ammonia, carbon dioxide, sulfur dioxide, ethyl chloride, or furon groups like R11, R12, R134A. So these are the basically primary refrigerant. Secondary refrigerant, generally these refrigerant first cooled by the primary refrigerant, then it used for the cooling purpose like ice, brine solution, solid carbon dioxide. So if we talk about the primary refrigerant in that halocarbon components, so these refrigerant generally contain one or more halogens, uh, chlorines and bromines, okay, and these are invented and developed by the Charles Kettering in 1920. Sold in the market under the name of different name. Basically, you can say ferrons, genetron, isotron, artons. So generally, these terms if you see, so generally they are talking the halocarbons compound. Out understanding merit they have, like they use in the domestic and commercial and industrial purposes. If we talk about the refrigerant, azeotrophs they are the refrigerant belong to this they are the refrigerant generally uh, which are a mixture of two or more than two refrigerant basically and behave as a pure refrigerant like R500 series. It consists refrigerant R12, R11 basically. Then hydrocarbon or organic compound refrigerant. So these generally are 50 methane CH4 chemical formula, then R172 170 ethane C2S6, R290 propane, which are generally the future refrigerant or generally used now. These are the refrigerant which are generally future refrigerant, which will be used or generally now the people are using in the refrigeration industry. So R290 propane C2H8, R600 butane C4S10, then R601 isobutane. Okay. So hydrocarbon organic compound refrigerant are the future of. Then inorganic compound refrigerant, if we talk, so like ammonia, water, air, carbon dioxide, sulfur dioxide. In that ammonia, which have uh, large amount of latent heat of vaporization, so it is preferred, but due to the toxicity in nature, generally it is not used in the residential purposes. It can be used for the cold storage purposes. Carbon dioxide generally used in the transportation industries for the refrigeration or air conditioning. If we talk about the desirable properties of a ideal refrigerant, so how we can select the refrigerant? How? Okay, so there should be some properties in that refrigerant or substance that can be used in the refrigeration or air conditioning. That are the three type of properties: basically thermodynamic properties, chemical properties, and physical property. If we talk about the thermodynamic property, there are thermodynamic property like refrigerant should have low boiling point, low freezing point, or sufficiently low freezing point. Okay, so that refrigerant can be operated at lower temperature limit, high saturation temperature, high latent of heat, and you can have high enthalpy of vaporization. Also, it should have low specific volume so that the volumetric efficiency or the dimension of the cylinder can be minimized. Okay, it should have low condenser pressures so that the manufacturing or construction cost can be saved. Okay, so such property generally come as the thermodynamic properties of refrigerant. Okay. If we talk about the chemical properties of refrigerant, so if we select the refrigerant, what should be the chemical properties of refrigerant? Okay, so first, refrigerant should be free from toxicity in nature. Okay, it should not the toxic. Second, it should not be flammable. Also, it should be non-flammable. Okay, otherwise, if person is sleeping inside the room or AC is working, if some leakages happen, and if it is high flammable, then there might be chances to fire. Okay, so for the safety purpose, the refrigerant should be non-flammable. And third point is the non-corrosiveness, corrosiveness. So you can see that corrosive is always harmful to the component or element, so it should be non-corrosive. Then non-irritating or odorless, it should be. Okay, so these are the basic chemical properties which refrigerants should possess to utilize in the refrigeration air conditioning industry. Then if we talk about the physical properties, so physical properties like a specific volume, specific heat, high thermal conductivity, low viscosity, high electrical insulation basically. So these are the five physical properties we should have in different manner, like low specific volume, low specific heat, high thermal conductivity, so the heat transfer can be easily transferred in the condenser or evaporator. Low viscosity, so that the pump work or the flow of the refrigerant should be easy throughout the piping system of the refrigeration. High electrical insulation, because the refrigerant go inside. Okay, because the refrigerant go inside the uh, compressor where their electrical wiring is there, and it should not have that low dielectric strength. Okay, it should have high dielectric strength, so the electric shock can be avoided. So basically it should have high electrical insulation. Then in physical property there are also the leakage uh, properties. So refrigerant should such that it can be easily detected. Like the LPG gases, we mix the components, so that smell can come out and we can detect the LPG leakage. So similar manner, refrigerant should have such quality that it should easily detect it. And availability, low cost, obviously easy handling, and it should have high COP, low power consumptions per tons of refrigeration, then low pressure ratio or pressure difference. So these are the other few properties which are useful to select the refrigerant. If we compare the different refrigerant, their COP and uses as kilowatt per tons of refrigerant. So here is the some comparative study of different refrigerant which are generally used in the refrigeration industry. So first you can see the COP, and second column we have Carnot. Carnot, the cycle which give the maximum COP. So it is not practical cycle, it is RDC cycle. So suppose Carnot cycle have the 5.74 COP, and if we take on that uh, COP value for comparative, then NH3 will be always lower than the Carnot COP, and it is 4.76. And if we compare with CO2, then it is around 2.56 COP, and sulfur dioxide 4.87, then R11 it should be, or here the furans F is repeated, generally it is R. Okay. So 509, then R12 4.7, R22 4.66, then R113 4.92. So these are the basically COP values of the refrigerant, and in respect that how much power that refrigerant is consuming while the air conditioning is running or refrigeration system is running. So you can see here if the COP value is 5.74, the kilowatt per tons, means if the AC have 1 tons of capacity, then it is generally using 0.62 kilowatt. Okay. And if generally ammonia is using, generally it take around 0.75 per tons of a kilowatt per tons power consumption, and CO2 1.4, which is very high. Then sulfur dioxide also low, 0.74, but it is the very toxic nature, so we cannot use. Similarly, CO2 generally used in transportation. NH3 also and medium toxic in nature, so residential purpose we cannot use. It should be used in the cold storage or away from the city generally. Okay. Here R11 have 0.71 kilowatt consumption power consumption per tons. Then R12, which is have 0.76 kilowatt per tons of power consumption. And similarly R22 and R113. So here you can see the ammonia have the uh, you can see the 0.75, or you can say 750 watts per tons. Means if the air conditioning capacity is 1 tons, then generally it consume around 750 watts of energy. Or if it is run for the 1 hour, then it will be watt hours. Okay. So then there are the property and use of commonly used refrigerant. You can say air, no cost involved, completely non-tax, completely safe. So air was used before, and now it generally used in the aircraft industry. Ammonia it highly used in the cold storage industry. It is highly toxic. Okay, so we can use it, we cannot use in the our air conditioning, which are in residential purpose. It has excellent thermal properties. It has highest refrigeration effect per kg of refrigerant, low volumetric displacement, low cost. So every uh, cost saving properties ammonia has, but due to the toxic in nature, we cannot use in the refrigerant in residential purpose. Okay. Then methyl chloride, which was used before, it is colorless liquid, non-irritating odor. Okay. And it has a specific gravity of 1.022 at atmospheric pressure. It's neither flammable nor toxic. Uses you can have it been used in the past in both domestic and air conditioning. Then if you see present time, what are the different refrigerant used in their application? Domestic refrigerator generally use one, two, but generally no, it is using R134A. Okay. And a small retail supermarket use R12, R22, R50. Air conditioning generally R22 and R601. No, they are using industrial purpose. You can see ammonia R717 and even R12, R502. Transport generally CO2 also be used. Here you can see R12, R502 and CO2 you can say. So then what are the different methods uh, that refrigerant leaks can be detected? So you can see the first method is device that get used for some large leakage is listening of hiss, the sound of leakage of the refrigerant. If it is large piping system or large leakage, then the person can directly detect the leakage of refrigerant. Okay, then there are second method, the soft bubble method, and generally the soft bubble apply over the piping system, and if the bubble is formed, then uh, the technician can say that leakage are from here generally. So this is the very cheapest and practical method to use the leakage detection in the refrigeration industry. Then third is the halide leak detector torch basically. So if we use this, we generally focus on the piping system, and if that light change its color, then we can see that there is leakages basically. Okay. So that is how the leakage being detected for the refrigerant industries or refrigerant leakages. Then how we can store that refrigerant. So their container or cylinder are different. They should uh, store in small pressure vessels as soon as possible. Okay, it should conveniently handle and during transportation and charging. Handling of flammable refrigerant require extreme precaution, because if it is blast or flammable, then something dangerous can be happen. Then you can have handling of sulfur dioxide should be very carefully taken, because it's very high in toxicity nature, and it can kill the person who is handling the sulfur dioxide refrigerant or gas. Okay, so it should be handled very carefully. So these are the, you can see the geometry or shape of different storage cylinder of refrigerant. So generally you have seen this small type of refrigerant cylinder where, and if it is the big manufacture unit, then they first they store in the big container, then the small retailer person, they take from that small cylinder, and then they distribute in the small cylinder like 5 liters or 3 liters container or 10 liters. Refrigerant nomenclature, if you there are some specific method to design or designate the refrigerant, but if you say the layman language, then generally the word R generally represent the refrigerant by manufactured grade name pherones or genitrons. Okay, all two second digit number are derived from methane, and third digit number are derived from ethane, and last digit generally represent the fluorine molecules in the. So if you have like here if you have R 1 2, okay, so it have two fluorine, or like it is a first, second, or third digit. Okay, so last digit generally represent the fluorine molecules. This one generally represent the uh, hydrogen or halocarbon, then carbons molecules, basically methane or ethane. Okay, so this is how the designation or nomenclature of refrigerant is taken. So there are that next digit to the last digit equal or one more than number of hydrogens atoms. Any atoms non accounted for the methane or ethane series. Then secondary reference, generally you have seen the brine, solution, ice, but their properties are uh, uh, should be good to use in the ice manufacturing industry, basically. So secondary refrigerant generally used in the used for large refrigeration plant. uh, Brine or glycol are used to carrying refrigeration from plant room to the space where it is hugely applied, and instead of directly obtained, it is by evaporating refrigerant at the place of application. Okay, so generally first it is cooled by some another refrigerant, then it is used to absorb the heat from the main object or storage place to reduce the quantity of refrigerant charge in the system and reduce the pressure losses also. Desirable properties you can have for the secondary refrigerant, like it should have low freezing point, low viscosity, so it can flow easily, low freezing point, so it can be used at the very low temperature, not flammable. As we all know, it should be not flammable, good stability, it should not reactive. So like chilled water is used as a secondary refrigerant. Okay, brine and glycol, these are also used as a secondary refrigerant. In the ice plant, generally secondary refrigerant are used. Then there is a ozone depletion potential. So as you know that the refrigerant are harmful to the ozone layer, but now that refrigerant we use, they are not harmful to the ozone depletion or ozone. Okay, because the scientists have discovered the new methods which don't have the capacity to harm the ozone layer. Okay, so if the refrigerant is harmful, then their ozone depletion potential will be high. If it is not harmful to the ozone layer, then their ozone depletion should be zero or very less. Okay, so if you have the CFC have linked to the depletion of ozone layer. If the CFC like chemical formula Cl2 F2 difluoro dichloro methane, then it react with the sunlight. If it is leakage in the atmosphere, so it react with the sunlight, and it result will be Cl2F2 and chlorine. So that chlorine generally molecules which link to deplete the ozone layer, basically. Okay, so ozone layer, this is O3, the ozone layer, and the chlorine molecules, and with sunlight it becomes ClO and O2. So the ozone layer will get depleted. So if the refrigerant is harmful to the ozone layer, we measure with the help of the ozone depletion potential. Then there are another global warming potential. So it is measure how much of refrigerant effect is given uh, or will have on the global warming in relation to the carbon dioxide, where CO2 has the one global warming potential, and this is usually measured over the 100 year. Okay, it is here, it is not present, so 100-year period. So if the CO2 have the potential of 1 in the 100 year, then we compare the other refrigerant that how much harmful they are to the environment. Okay, So here you can see some value like R11. It have very low ozone depletion potential, but it has high uh, global warming potential. Or these represent generally, although use of R1 is banned, but it was used at the datum for some bottom lines purposes. Okay. And R12, uh, that represent value you can have the ozone depletion potential is 0.05, very low, and global warming potential is 1700. Okay. And these represent generally now going to phase out or already phase out. So here you can see after January 2000, no more virgin refrigerant can be used in existing system, and after 2004, no more recycled refrigerant R12 can be used in existing. So there are some uh, replacement refrigerant of R12 that we will see in future refrigerant. Then this is also you can see most of our refrigerant have this refrigeration have this refrigerant, okay, and which is at ODP 0 and global warming potential 1300. Similarly, R40C it have uh, 0 ozone depletion potential, but it have global warming potential 1600. So the people or researcher are searching to have the low global potential uh, for the refrigerant R1 R410A. This is the refrigerant also used. Similarly, R147A refrigerant is also used. Then if we talk about the future refrigerant, these are the isobutane like R600A, the designation propane R290, propylene R1270, ammonia R17, carbon dioxide. So if you see, know the refrigeration air conditioning, generally these two refrigerants are using because they are low global warming potential and low ozone depletion there. So that's all for today's lecture. Thank you, all of you. Have a nice day. Thank you for watching this lecture.